Okay, great. So yeah, it's great to have you, Dr. Leta Pilic.
Thank
Is that how
you.
you pronounce it?
Yes,
Yeah.
Pilic.
So,
Yes. Thank you.
no, it's great to finally sit down with you. And of course, my idea is really to have a lot of discussions with experts like yourself who have a very particular area of interest, or where you know the area that you did your PhD in, which is really at this intersection of nutrition and technology, and really getting that kind of angle out there, because there's so much misinformation and people want to know, but then they're not sure where to find it, and then when they do find it, it's not really easily understandable. And so it's kind of nice to just have a very informal conversation around it and to see what your experience and what your learning has been. And also as a nutritionist, you can explain it in a good way. So do you want to tell us a little bit about yourself before we start?
Yes, of course. Well, so I am a nutritionist. So my undergraduate degree is in nutrition science, which I then followed with a master's in public health. So not really personalized nutrition.
Right.
However, while I was doing my final dissertation for the master's, my mentor at the time was telling me all about the nutrigenetics and kind of the exciting prospect of using it for public health, I guess. And I've decided to do a PhD in the topic in nutrigenetics. And I found a PhD that was exploring how our genes interact with salt intake and how that affects our blood pressure. So I've spent 3 years exploring basically salt sensitivity of blood pressure and how genes affect it, and then also trying to link it with our taste perception. So how are we able to taste salt and how that drives our salt intake, actually, and kind of again looking at the genetic basis of our salt taste perception. And I continued lecturing and researching in the area of nutrigenetics. So I'm a lecturer at St. Mary's University, where I teach on our master's program in nutrition and genetics. I also do research, obviously, in the area. So I'm an active researcher, exploring, well, different areas. I would say it's not solely salt sensitivity and blood pressure, but nutrient gene interactions in relation to chronic disease, such as cardiovascular disease, but also type 2 diabetes, and still looking at the links between genetics and taste. But I also work with other nutritionists and professionals as part of kind of my business role, let's say, where I kind of help them as a consultant, and I also work with clients offering nutrigenetic testing.
Right. So you've added entrepreneur to the title as well, which is great.
Well, I mean, well, yeah, if you can call it that, but
yeah, we do. So before we dive then in, can you explain what the difference is between nutrigenetics and nutrigenomics, because they are commonly kind of mixed up in the everyday language?
Yes, yeah. So, well, what we mostly, I would say, use in personalized or gene-based personalized nutrition is nutrigenetics, and nutrigenetics explores how genetic variations, so genetic differences between us, affect the way we respond to different foods, nutrients, lifestyle factors, and how that in turn affects our health. Whereas nutrigenomics is kind of the other side of the story, and it explores how food or nutrition, nutrients, lifestyle factors, again, it doesn't have to be just the diet, how they affect gene expression, so the way our genes are kind of expressed on the outside. So it's just kind of the other way of looking at it. But we are focusing mostly on how genetic variations, genetic differences affect us, and how we all respond differently to the same foods, maybe because of these genetic differences.
Yeah. So let's start then on that note. Like, what is the genetic differences in terms of salt sensitivity?
Mm-hmm. There are many. I think obviously we don't know them all, but we know that our blood pressure and our salt intake are regulated by genes that are expressed in our kidneys. Mostly, so we are looking at these tiny differences or one letter difference in our genetic code in genes that create these proteins expressed in our kidneys that regulate blood pressure. And then based on these differences, so literally one genetic variation it can be, we respond differently to the same amount of salt in our diet, or we may respond differently to the same amount of salt in our diet. So I can have a genetic variation in ACE gene, that's part of a renin-angiotensin-aldosterone system, for example. And I can have a variation that predisposes me to be salt sensitive, which means that if I eat large amounts of salt, my blood pressure may increase significantly. Whereas you may have a different variation in the same gene, and actually your blood pressure isn't really going to react to these large amounts of salt. So you would be considered as salt resistant.
Right.
So there are many different genes obviously involved, but that's kind of the idea behind it.
Yeah. So when you say there are many genes, when we are specifically looking at salt sensitivity, how many are we looking at? Are we just looking at one? Are we looking at a cluster? Are we looking at 5,000, 5 million? Like what is that number?
Yeah, that's a very good question. Well, what I always try to explain to our students as well, and in my own practice, is we tend to avoid, or we should avoid, kind of predicting a specific disease by just using genetics.
Yeah.
If we were to predict someone to have high blood pressure, let's say, we would need to use thousands of genes and genetic variations. And when it comes to salt sensitivity, we probably don't know as many because salt sensitivity is very difficult to diagnose. So when we talk about obesity and kind of genetic predisposition to obesity, we are talking about measuring someone's height or weight and then doing a large study that explores many genes that would be associated with someone's BMI. With salt sensitivity, to diagnose it, people need to follow a specific dietary protocol that lasts at least 2 weeks. So it's impossible to do very large scale studies to be able to identify thousands of different genes that would be associated with it. So these are smaller studies. So I would say for now, we only have a handful of genes that there is sufficient evidence that they interact with our salt intake and in that sense affect our blood pressure. So I think probably the ones that we can use to provide practical dietary advice would be maybe 2 or 3 genetic variations, actually.
Yeah. And then if you say, okay, those 2 or 3, who is really at risk? Who should really be worried or should be sitting up and listening when we're talking about salt sensitivity then?
Mm-hmm. Well, we have specific groups that would be at particular risk of salt sensitivity. And these groups are older people, postmenopausal women, and people of African descent. However, I would say that doesn't necessarily mean that everyone else should just be thinking, okay, I mean, it's kind of useful to know it. Because actually, for everyone, if they are able to find out their salt sensitivity status, and if they do have these variations that put them at potentially higher risk of being salt sensitive, then preventing high blood pressure even from happening is definitely more likely. So I would say these 3 groups that I've kind of highlighted, but I think in general, the younger we are, the more useful it will be to know this.
Yeah.
Um,
Yeah.
yeah.
Very interesting. And of course, menopause is a huge topic. Like women's health
Mm-hmm,
is just like,
mm-hmm,
gone onto
mm-hmm.
the stage like big time. What is the deal there? Can you explain, like,
Mm-hmm.
mechanism wise, why postmenopausal women? Why so specific? Why
Oh,
not
well,
fertility? Why not, preconception? Why?
yeah, well, Mariette, well, as women, when estrogen obviously starts to decline, I think everything goes downhill. Obviously, I'm not trying to put a negative spin. No, things are, but
No,
obviously
no
we,
offense taken. I'm in a bubble. No offense taken.
no, but yeah, unfortunately, obviously, estrogen is very protective for us
Yeah,
in a number of ways. So in this case, it actually then the decline in the levels of estrogen um, put more pressure on our kidneys. This renin-angiotensin-aldosterone system isn't really working properly anymore. It's not being suppressed sufficiently when it should be suppressed if we eat
yeah,
large amounts of salt. And also our blood vessels are potentially unable to dilate as much as they were before, which then obviously if
yeah,
we have high intake of salt, here we need to appreciate that even if we are salt sensitive, so if we are genetically predisposed, but our salt intake is adequate,
yeah,
then we probably won't develop high blood pressure. So this is only if we have this kind of an environmental component here. So salt intake, if it is
yeah.
high, then we are at higher risk.
Yeah. So if you were talking about salt intake, but most people don't know if they are salt sensitive or not. They just say, hey, I've got a bit of blood pressure, or my grandmother or my parents had high blood pressure. Like, how is the recommendation in terms of salt different between those who are salt sensitive and those who are not, even if they don't know it?
Mm-hmm. That's a very good question, and I think that no one actually knows this
Yeah.
so
Yeah.
so properly. So um, I would say in nutrigenetics specifically, if we talk about kind of this area of personalized nutrition, so gene-based personalized nutrition, we don't really have specific dietary guidelines that are maybe published by experts that would then make a difference, let's say, between a personalized recommendation for salt based on someone's genetics because they're salt sensitive, and then a general recommendation for salt. So that's completely up to the either a genetic testing company or a practitioner that is in this area. So what I would say, probably, well, here in the UK, general recommendation is no more than 6 grams. WHO recommends 5 grams per day, salt per day. I would say probably go closer to the reference nutrient intake. Here in the UK, it's 4 grams.
Right.
So go a bit lower than the recommendation, although we know that currently we are eating double the amount, even triple. So how realistic is that actually to achieve this?
Yes.
That's a different story, and we need to consider that as well.
So you have a clinician hat as well. And so if you say to people, like, you need to limit your intake to 5 grams a day or 4 grams a day, like, what does that mean? Like, people don't know what that means. So as a clinician, how do you explain that to people in the whole sense, like your whole diet or your whole dietary pattern or approach? How do you address that?
Yeah, I mean, it's very difficult. So we know that we need to, obviously, we can't just even say to someone, well, yes, you're salt sensitive, so you need to cut down your salt intake to 4 or 5 grams, exactly, because what does that mean to them? How can they do it? So maybe not pushing the numbers so much, but giving some more practical advice that they can adopt. So either if they're not really aware of reading the food labels or trying to achieve this pleasure from food, because we obviously need to
Yes.
enjoy our food, and salt is very important in the taste of food. So then trying to use different seasonings, either some chilies, some lemon, some herbs, so try to still make it kind of tasty without using too much salt. So really kind of focusing on these more practical aspects of it than just focusing on the
Yes.
number itself.
Yeah. And you touched there on taste and how food tastes. So how does taste perception then fall into this concept of sensitivity or the genetic predisposition to your taste perception of salt? Because that's also fascinating.
Yes, and I would say that we often confuse, I think, salt sensitivity of blood pressure and then salt taste sensitivity. These are two kind of different concepts, let's say. So when it comes to taste, we know that it's, well, to me definitely is, and I know that research suggests that it's the number one factor that drives us to eat the food, or to choose the food that we eat, at least one of the key drivers. So our genes, obviously, we have taste receptors in our tongue.
Yeah.
That then enable us to taste. In this example, it's salt. So we have these taste receptors, of course, are created by different genes. And we can have different variations of these genes. So sometimes we have a variation or a version of a gene that's a bit more lazy, let's say, so that the receptor doesn't work as well. Let's call it like this. If this is the case, when we talk about salt taste sensitivity, so our ability to taste salt, if we have this lazy receptor, we may not be able to perceive the saltiness as intense from food. So we may want to eat more to achieve kind of this sensory pleasure from food. And of course, that would be how then our genes drive our salt intake. So that's kind of the key link, I would say, between the two.
And then how does that tie in with, people say, oh, I crave salt. Is it then is it habitual? They are used to eating salt, or is it the genes that is driving them to crave more? Like, is there a biochemical reason for that is always a very interesting conversation, always comes up at dinner parties. So it's kind of like, what is driving what?
Well, I think there is a mix. So you mentioned habit; it definitely plays a huge role. So some research has really shown that we are able to train our taste buds. So if we kind of put effort in, let's say, and start eating less, then our taste buds are going to get adjusted to that. So we can change, by changing our habits, we can also change our perception of saltiness. Genetics, I mean, I would say that definitely there is, for some people, they're just going to kind of, I don't know if it's a craving, but they are definitely going to need more, because of the reason that I mentioned, is that they're just not going to find it as tasty if it's not salty, and that's definitely because of genetics. And then obviously, if we are exercising, working in a very hot climate, and then really the body needs to replenish the electrolytes, that's where I would say the actual kind of physiological craving comes from.
Yeah, fascinating. So can you tell us a little bit more? I mean, you talk now about the kind of the salt sensitivity. We just bring it back to, again, the actual technology, which is, of course, we also want to explain in terms of how does that actually work? Because it's not like you going to go to your GP and then get a quick test, or go to your pharmacist and find out what your genetic predisposition is. Can you tell us a little bit about how the technology actually works for the everyday kind of person?
Yeah, well, when it comes to salt sensitivity, so we're going to our blood pressure, let's say. We we don't have the technology yet to actually be able to diagnose someone. So there are some efforts where potentially we can just use a simple urine sample from someone, and then it's able to measure specific proteins that would differ between people that are salt sensitive and salt resistant, and then based on that we would be able to know. But that's kind of not even in some testing. It's still in a research stage, let's say. So when it comes to specifically to this topic, I would say, or at least what I'm aware of, is that we are not there yet, that we are able to easily find out about our salt sensitivity status without having a genetic test. But when we do a genetic test, we are talking about probability. So we can't say with 100% certainty, yes, you are salt sensitive. And then when it comes to, obviously, if we think of salt sensitivity, it's important to know then your salt intake, if you are eating too much, not eating too much, and it's very hard to measure this as well. So there are some efforts from researchers also with some tooth sensors that can then measure the salt intake, which potentially would give you a more accurate or more kind of real-time information that then you can then adjust your salt intake based on that.
So I think, I mean, because even people can actually use like food trackers, food analysis, apps and things like that to actually track their salt intake as well, to see. Even I think public health also had apps that managed for you to track your salt and sugar intake and then see how that converts kind of into your food. So I think technology does definitely play a role, because I think when it comes to making it visible, it's quite difficult for people to actually understand what is that. I eat bread, I eat cheese, I eat, I eat my bag of crisps. All these different things certainly add up that people are generally not, that much aware of. So I think that is really an important kind of factor. But how do you see the future? Because of course, nutrigenetics is not kind of an everyday kind of technology for everybody. Not everybody's getting a test. How do you see the future, considering that we have such a huge problem with cardiovascular disease, risk of stroke, dementia, all these? I mean, it seems like it's more important now than ever before, but it's not. It's not that people actually know anymore. So what is the future?
Well, a personalized nutrition, I would say, definitely. And not just trying to, because it's the topic, but I do really think that we maybe not make it, as fancy. We don't need to potentially measure all sorts of biomarkers and then put it in like a fancy algorithm or anything like that, which I'm not saying that it doesn't have its place, of course, but maybe it's not something that everyone can use. And when it comes to salt, it's like, it's more deprived areas as well, and people that really don't have access to it. So my vision kind of would be really to try to, genetic testing is really cheap. So can we at least have this piece of information and make it accessible and make it a bit more mainstream, so people can have this information and then they at least know about the likelihood of them being salt sensitive. And it's very easy to do. And well, if we were to convince the governments and the policymakers that probably it would save much more money than spending money on treating cardiovascular disease and hypertension, I would say that that would definitely be something that I would really like to see. So it becoming a bit more mainstream and really trying to target the groups that would need it the most. So maybe the companies as well should, don't know, create part of the offering. I know it's not very commercially savvy, but to try to do it for free or for very cheap for parts of the population that may really benefit from this information.
Yeah, very interesting. Well, Leta, that was a great explainer. I'm sure we'll have more interesting topics to talk about in terms of nutrigenetics and your area of expertise. But thanks very much for your insights and your knowledge and making it so accessible and understandable. And I found that really fascinating. Thank you so much.
Thank you, Mariette. Thank you very much.